carboxylic acids, and esters. So 4 uses of esters: food flavorings, perfumes, solvents, and plasticizers. 4 uses of esters: food flavorings, perfumes, solvents, and plasticizers. Esters are organic compounds that contain COO group. Esters are made by reacting a carboxylic acid with alcohols. Esterification reaction: heating a carboxylic acid with a strong alcohol in presence of a strong acid catalyst. The acid catalyst used in esterification reaction is concentrated sulfuric acid. 2 parts when naming esters. The first part comes from the alcohol. Second part comes from the carboxylic acid. Naming esters: first part comes from alcohol, second part comes from carboxylic acid. And if you want to name esters in a branch chain, we want the number of carbons from the carbon atoms in the COC bond. Carboxylic acids plus alcohol esterification reaction from ester plus water, with the water is the byproduct. So you've got your carboxylic acid plus your alcohol, reversible reaction H plus and reflux, strong acid catalyst under reflux, form your ester, RC double bond OR, plus your H2O, your byproduct water. This is an example of a esterification reaction. A esterification reaction is an example of a condensation reaction. Why is it an example of condensation reaction? As it releases water. This oxygen comes from the alcohol. So when naming esters, the first part comes from the alcohol, second part comes from carboxylic acid. The ester, this oxygen comes from the alcohol, and the rest from the carboxylic acid. Acid hydrolysis: you want to reflux ester using a dilute acid. Ester plus H2O, reversible reaction H plus reflux to form a carboxylic acid plus an alcohol. Alkaline hydrolysis: ester plus OH minus. In this case, it's not reversible reaction, it's only reflux to form a carboxylic ion plus alcohol. However, with both acid hydrolysis of the ester, alkaline hydrolysis of the ester, we both are forming an alcohol. So reflux ester using a dilute alkali, NaOH, hydrochloric acid, sulfuric acid. Whereas acid hydrolysis, hydrochloric acid, sulfuric acid. Examples of dilute alkali, OH minus. So naming carboxylic acids, we want to name the longest carbon chain, remove the E, add dash oic acid. Ester plus water, water byproduct. Carbonyl group is located at the end of a molecule in a carboxylic acid. That's really important, located at the end of the molecule. It's very important as all the functional groups are numbered starting from that carbon. The carboxylic acid reacts with metal carbonates to form a salt, CO2 and H2O. CO2 fizzes out the solution when carboxylic acids react with metal carbonates, therefore could be potentially dangerous. Carboxyl group, a group containing carbonyl group and hydroxyl group. Hydrolysis is when a substance is split up by the addition of water, or by water. Esters are hydrolyzed to form water. Polar liquids. Now this is for the 4 uses of esters: for food flavorings, perfume, solvent, and plasticizers. What esters, the polar liquids, so polar organic compounds will dissolve in them as they have a low boiling point, and therefore they will evaporate easily as the good solvents. Plasticizers, a use of esters plasticizers as well, as the added to plastics during polymerization to make it more flexible. And for the polar liquids, they evaporate easily, so good solvents / glues. And why are carboxylic acids weak in water? They partially dissociate to form a carboxylate ion and a H plus ion. So RC double bond OH, carboxylic acid, reversible reaction from RC double bond O minus, carboxylate ion plus your H plus ion. 2 types of hydrolysis of esters: acid hydrolysis, alkaline, aka base hydrolysis. And acid / alkali is used as water is too slow, and therefore the acid / alkali is used to speed up the reaction. I think that's it for this whole thing. I just want to go through these reactions, the mechanisms, reactions again. So 2 parts for naming esters: first part comes from alcohol, second part comes from carboxylic acid. Name esters in branch chain, number of carbons from carbon atom, COC bond. Carboxylic acids plus alcohols from ester plus water is a reversible reaction with H plus and reflux. RC double bond OH plus ROH. H plus reflux reversible reaction, RC double bond OR plus H2O OH H which is the byproduct. So in exam, if it says what's the byproduct of reacting carboxylic acid with alcohol, it's water. Water is the byproduct. And this is a esterification reaction, and what is example condensation reaction as it releases water. Then you've got acid hydrolysis, refluxing the ester using dilute acid. Ester plus H2O, reversible reaction, H plus reflux to form carboxylic acid plus your alcohol. Acid hydrolysis, a reflux ester using dilute acid. Ester plus H2O, reversible reaction, H plus reflux to form your carboxylic acid plus your alcohol. Alkaline hydrolysis, bracket, could also be called base hydrolysis in the exam. Ester plus OH minus, and in this case there is no reversible reaction. H plus reflux is carboxylic. It's ester plus your H2O arrow, ester plus your OH minus arrow under reflux to form your carboxylate ion plus your alcohol. So in acid hydrolysis, you form your carboxylic acid plus your alcohol from the ester plus H2O, reversible reaction, H plus reflux from carboxylic acid plus alcohol. Alkaline bracket base hydrolysis is ester plus OH minus, the dilute alkali with reflux, not a reversible reaction, just reflux, arrow reflux, to form your carboxylate ion plus your alcohol. So acid hydrolysis from carboxylic acid, alkaline hydrolysis from carboxylate ion, and you both forming alcohols in both reactions. So reflux ester using dilute alkali, example of dilute alkali OH minus, examples of dilute acid, hydrochloric acid / sulfuric acid, could be asked about it in the exam. And here the oxygen comes from the alcohol. So for esters, naming it, first part comes from alcohol, second part comes from carboxylic acid, and that is the end of this video.